Hey team, this is a part 2 video, follow-up from the previous video that goes through Roadrunner version 1.0 tuning. At the end of that video, we basically had a robot that was driving, doing this manual feedback tuner, op mode, driving forward and back, and we did a little bit of tuning on a few different gains. The gains we talked about were our axial gain, our heading gain, and our lateral gain. And that basically means how much is the robot going to try and correct itself when it's not perfectly lined up. We did a bit of tuning and ended up with a robot that, kind of followed the line. And you can see that here on the setup. On the right here, we've got the green line is the line the robot is supposed to be following, and the blue is where the robot actually thinks it is. So what we're going to do is do a little bit more tuning, a little more in-depth here. It seems like our robot seems to work well when driving forward and backward in a straight line, but if you've actually used this on the field after a while, you may have noticed that the robot doesn't always turn correctly or follow curves or arcs the way you might want it to. So we're going to go back in here and do a little bit more in-depth tuning of those three gains and kind of see how we can change our robot's behavior by adjusting those values a bit more. As I mentioned at the end of the last video, the robot does drift. So if you look at the robot on the field right now, it does kind of bias itself to turning towards the right. On our capture on the left, you can see, or excuse me, capture on the right, the green and blue lines here. The robot doesn't know it's drifting. It thinks it's following those lines perfectly. In real life, it does drift a little bit, and that's just because our sensors aren't perfect. Our gyro doesn't always give perfect readings, and over time things change like that. For a 30-second autonomous, this shouldn't matter, but if you do see the robot drifting on the field, don't worry too much about that. Really what we're going to be trying to adjust right now is these green and blue lines to try and error correct a little bit better. So if you were reading through the Roadrunner docs and following along in the last video, you may have noticed it gave you some instructions on how to actually set these values that involve being a bully to your robot, kind of pushing the robot around and getting it to respond to disturbances. So we're going to go ahead and do that now. Our current gains that we ended with was a axial gain of 5. That's our forward and back. That means we basically start and end at the start and end of the green line, top and bottom here. We have a heading gain of 1, which is our rotation. And you can see the robot is a little bit off when it gets towards the end, but we're not telling it to turn, so it's not too far off heading-wise anyways. And a lateral gain of 1. Again, our robot biases strafing to the left and turning to the right just because of the mechanics of the robot. So you can see it as it drives forward and backward. It tends to kind of curve to the left there. That blue line seems to be always to the left of the green line. So to adjust these gains, we're actually going to introduce some disturbances into the robot. And what that means is pushing the robot around on the field. So as the robot's driving, we can introduce different types of disturbances. Some of those disturbances are going to be axially forward and back. They can be laterally left and right, or they can be rotationally or changing that heading as well. So to do that, we're just going to start pushing the robot around on the field. So make sure you're in a safe place when you do this. Make sure, the robot isn't going to fly off the tracks or do anything crazy. We do have a nice big open area here. So the first disturbance I think we're going to try is just a lateral one because those seem to be the easiest. So as the robot's driving, I'm just going to push it a little bit off center or pull it a little bit towards me as it's driving down the field. And as we do that, you can kind of see how much the robot responds. And it doesn't fight back very much. So just a gentle nudge in one direction or the other. The robot kind of takes a while to correct itself. So depending on how fast you're running your autonomous, that may or may not be sufficient. So what we're going to do is actually change our lateral gain maybe from 1 to 3, click save at the top, and then try and do that same test and see how the robot responds. So now if I push or pull the robot towards me, it actually fights back a little bit. I have to get a better nudge on it now to push it. But you'll see it actually tries to error correct a lot faster. And you can see that on the graph as well. So as I do that same thing, trying to push the robot laterally, it tends to correct a little bit better. So let's even change that a little bit higher to a 5 and see how it behaves. Typically when I'm doing tuning with this stuff, I like to change the value, almost go too far with the value, slowly increment it until it gets to where you want. But try and go past that value and see if you can get it to misbehave so you kind of know what your upper and lower bounds are. So this seems to be correcting a lot better now. You can see as we nudge it, the robot pretty readily tries to get back onto that path. It does overshoot a little bit. You can kind of see it kind of makes that snaking line as it comes forward. But I think we're okay with that. You can also see on the tracking line, if we just let the robot drive straight, again, we know it's a little crooked on the field. That's just because of the drift of the robot. We've been running for a few minutes now, but our blue and green lines are almost perfectly on top of each other now. We still drift a little bit to the left, but it seems to correct it as soon as it's off. So the other gain we can play with is the heading gain as well. This would be rotationally. So we're kind of fortunate that two of our drive motors stick up. That gives me something easy to grab onto to try and twist. So keeping the robot in a straight line, we're just going to kind of give a rotation motion to the robot and kind of get it off center. And it's kind of funny. You'll see the robot actually knows it's off center and can adjust the drive motors to keep staying in that line, but it doesn't necessarily try and keep the same heading. So this is important maybe if you have a camera on the front of the robot or if you have some kind of intake or delivery mechanism. Even if the robot's in the right position, axially and laterally, it might not be in the right angle facing the correct direction. So let's change our heading gain to 3 and see how that behaves as well. Change to a 3, click save, and then we'll just rotate the robot. And now you can see it tries a little bit harder to rotate itself back. If we rotate the other way, it seems to come back. You can also try and simulate other disturbances in the field, maybe a sample in the way. If you put some blocks in the middle of the field, we'll kind of see how the robot wants to correct itself. Or if something were to get stuck on one side of the robot and cause it to twist, you can see how the robot behaves. And just changing those gains up or down not only gets you that straight tracking line, but will also try and give you better heading as the robot does different trajectories as well. So keep all that in mind as you're changing your trajectories in your robot, getting it to turn and face various directions or follow arcs or strafe differently. You can always go in and change these parameters, that axial gain, the heading gain, and the lateral gain to try and get the robot to face the direction you want and stay on course as possible. Also remember, if you change anything about the robot physically, if you change how much it weighs or the gear ratio on the motors, or I don't know, any of the friction or stuff, if you replace a wheel or a bearing or something, that might change as well. So you might have to go in and just run the stop mode, retune some of those gains, maybe bump them up or down a little bit, and see how the robot behaves. That's it for this video. It was a quick one, hopefully just explaining a little bit on how to tune those values a little bit more. Also, don't forget, even if you type them in your config, make sure you put them into your code and upload that to the robot. Otherwise, when you close this dashboard out, those changes will not be saved in your code. So make sure you go ahead and copy those values into the code so that they work when you're running your op modes. All right, thanks for watching. Good luck.